Welcome back to our channel. Throughout the previous videos, we have gone through the differentiation of logarithmic functions, trigonometric functions, exponential functions, basic differentiation rules such as the product rule, the chain rule, the quotient rule, and many other different rules. So from this video on, we are going to start the problem solving series, the first wave, and we are going to start with the first question, which is written just below. So let's start the question. The aim of this question is to differentiate y, which is equal to x squared plus 3x, all that times sine x. So first of all, when we have such a question, what is the first remark we can make? The first thing we can identify is this question is made up of two different functions. That is, this first function and this second function, and these functions are multiplied by each other. What does that tell us? That tells us that y can be written as a product of two functions, where f of x, our first function, is x squared plus 3x, and g of x, our second function, is sine x. So perfect. So the first thing, after identifying that y can be written as a product of two different functions, we then need to reflect on what rule can we then use to differentiate this function. What rule is applicable to functions which can be written as a product of two other functions? From our memory, we recall well that it is the product rule. And what does the product rule state? The product rule states that if y is equal to f of x times g of x, then y prime is equal to f prime of x, g of x, plus f of x, g prime of x. So in this question, in this expression, we have four different terms. Out of these four different terms, two of them are already known, leaving us with f prime of x and g prime of x to determine. So that is where we should start right now. The first thing, f prime of x. First of all, we rewrite our f of x, which is equal to x squared plus 3x. Now f prime of x is the differential with respect to x of the function x squared plus 3x, which is equal to the differential with respect to x of x squared plus the differential with respect to x of 3x. This is from our sum rule. And this then is equal to 2x to the 2 minus 1 from power rule plus 3 differential with respect to x of x, that is the constant multiple rule, giving us 2x plus 3 times 1x to the 1 minus 1. This gives us 0. This gives us x to the power 0, which is equal to 1. So this leaves us with 2x plus 3 times 1, which gives us 2x plus 3. So I've gone through the first step of this question, finding f prime of x. This leaves us now with the second question, the second step. How do we determine g prime of x? First of all, what is g of x? G of x is the function sine x. This implies that g prime of x is then the derivative with respect to x of the function sine x. And if we recall well from the derivative of trigonometric functions, the derivative of sine x gives us the function cos x. So we can then say that we have all the four terms which we can use to come out with the derivative of our function. This leaves us one step, substituting each function into our final expression. So what does our final expression say? It states that y prime is equal to f prime of x. What is f prime of x? From our previous differentiation, f prime of x is the function 2x plus 3. That is 2x plus 3 times g of x. What is g of x? G of x is the function sine x. Plus, what is f of x? F of x is the function x squared plus 3x, x squared plus 3x times g prime of x, which is the function cos x. After having our general expression, we then need to simplify it to the simplest form. This leaves us with 2x sine x plus 3 sine x plus x squared cos x plus 3x cos x. Note that I am expanding these brackets in an attempt to simplify the question. So if upon expanding the brackets, I notice that these questions cannot be simplified more, then the simplest form is going to be this form which had the bracket. So let's identify, can this expression still be simplified? Question mark. The first thing we notice is this expression cannot be simplified. Why can't it be simplified? Because each and every of the terms are unlike terms. This leaves us with 2x plus 3 sine x plus x squared plus 3x cos x. And this can be written as, or this can be identified as the simplest form of our equation. This leaves us with one conclusion. Therefore, the derivative with respect to x of our function, which is x squared plus 3x sine x, x squared plus 3x sine x, is 2x plus 3 sine x plus x squared plus 3x cos x. We box our answers. So let's move on to our second question. What does our second question say? Differentiate the function y equal to e to the x on 1 plus cos of x. When we look at this question, just like the previous question, we identify a numerator and a denominator. What does that tell us? We are working with a fraction. Sorry, but we can, let's not say fraction, but we are working with a function which can be expressed as one function divided by another. So what's the first thing to do? We identify each function. So we'll say, let our f of x be equal to e of x, e to the x, and g of x be equal to 1 plus cos x. Knowing already that our function y can be written as one function divided by the other, or g of x divided by f of x, what rule do you think can be used in this case? Of course, there is only one rule. There are many other rules, but in this case, the simplest and fastest, or the easiest to identify is the quotient rule. And what does the quotient rule state? It says that the derivative with respect to x of a function f of x on g of x is equal to bottom d top, that is g of x d top f prime of x minus top d bottom all over bottom square. So in this expression, we're having several terms which we need to calculate. Let's start with our first term, f prime of x. What is f prime of x? Is simply the derivative with respect to x of the function e of x. And if you can all remember from our video on the derivative, or the derivative of exponential functions, it was well mentioned and well derived that the derivative with respect to x of the exponential function e to the power x remains itself. That is, it remains unchanged. So this gives us e to the x. So let's move on to our denominator. The derivative with respect to x of our denominator g of x, which is same as the derivative with respect to x of the function 1 plus cos x, is same thing as the derivative with respect to x of our function 1 plus the derivative with respect to x of our function cos x. Derivative with respect to x of our function 1 leaves us 0. Why? because it was well said that the derivative of any constant gives us 0. So this leaves us with 0 plus, from our video on the derivative of trigonometric functions, it was well shown and well proved that the derivative of the function cos x gives us negative sine x. So this can then boil down to negative sine x. Our next function to calculate is the square root of our denominator, which is g of x squared. What is g of x? G of x is the function 1 plus cos x, and all this squared leaves us with leaves us with 1 plus 2 cos x plus cos squared x. We could expand it, or we could still leave it in this form, but for the continuation of this question, I'm going to use it in this compressed form, and if needed, I will then use the expanded version. So let's replace each term in our initial expression of our question, of our problem. So the derivative with respect to x then of our function y, which is equal to bottom g of x times f prime of x. What is g of x? G of x is the function 1 plus cos x times f prime of x, which is the function e of x, minus top, which is f of x, e of x, the bottom, which is 1 plus cos x, all that squared, all divided by the square. But sorry, I made an error. The derivative of the bottom is not this. I used the square of the bottom as the derivative of the bottom, which is wrong. And what is the derivative of our bottom? Minus sine x, all that now divided by the square of our bottom. This leaves us with the expression e of x. We can factorize e of x on both sides on the two equations, since it's common on both sides, leaving us 1 plus cos x minus plus sine x, all divided by 1 plus cos x squared. So what can we then conclude? Our conclusion can then be written as the derivative, that is the derivative with respect to x of our function, what was our function again, sorry? E of x on 1 plus cos x, e to the x on 1 plus cos x is e to the x 1 plus cos x plus sine x divided by 1 plus cos x, all that squared. What do? We encase, or we box our answer. So thank you very much for following throughout this video. We are waiting for you guys on our next video, which is still going to be a question in this our problem solving series. Thank you. Bye.